Okay, hi, multivariable. So these, every now and then you will get a screencast, and this is a screencast. And because there was no homework, like traditional math homework today, I thought what I'm going to assign for homework tonight, even though I said no homework in class, I know I said that, I am going to have you watch this screencast. And when you have a screencast, I will use these screencasts to either answer questions or maybe we'll finish class. We couldn't get and I just want to finally finish over Nick, Braden, Caroline, Thomas, Griffin, that class, okay? We were able to work through many curves that pass through different combinations. I think they did four. I think they did y equals 0, y equals x, y equals x squared. We even tried y equals sine x. All of those limits gave us 0, right? The other section of this class, Adam, Oliver, Ryan, Matthew with the melodic voice, I don't think we covered as many possible paths. So that section, there may be some gaps in this, but either way, I want to pick up with, this is really kind of where my larger Griffin is. The point is everyone can follow this, okay? So we tried x, y, 0, 0. We tried along the line. We're very we found that they all and the conversation we were having was we're so tempted to say that because we tried these 4 paths and the z value being approached is 0, well, that then this surface approaches 0. And that is actually not something we can conclude because we have to try all infinite paths. And the way the story goes is, well, it's actually impossible to try every single path that passes through 0, 0. And so what do you do? And I will kind of continue this conversation of what do we do? Like how is it possible to become close to exhaustively trying every possible path? I'll continue that conversation tomorrow. But the current homework I now what's more y equals 2, right? Now, and notice this curve here does pass the point 0, 0. And this point, the curve, I should rewrite this way, right? And I could say this, well, x of t, if x equals t and y equals cube of t, then you have to know that f of t, comma, cube root of t, right? This here is going to describe the path, quote unquote, above this cube root function of the xy plane on the surface, right? We have to know what this means. And f of t, comma, cube root of t equals t times the cube root of t cubed, that's the xy cubed, all over t squared plus, what's this? T squared plus, okay, cube root of t to the 6th. And I'm going to now simplify. This becomes t squared all over, 2t squared. Oh goodness, and this equals 1/2, right? So this here, if I were to ask someone, what does this describe? This describes the path, right? The roller coaster track, to use Coach's analogy, the roller coaster track above kind of the shadow on the ground, y equals cube root of x. Now we know f of t the limit of f of t, comma, cube root t as t approaches 0, well, this is f of t comma cube root of t. I simplified it, but we clearly see that this limit equals 1/2. And now we kind of raise our hands and put hands, because I have found a path, so to speak, this path right here, that passes through such that the z value being approached, right, contradicts a prior z value, okay? And so the conclusion here is, therefore, the conclusion is the limit as x comma y approaches 0, 0 of y. This limit equals a non-existent. Okay, the limit does not exist, and I just abbreviated f of x, y. You know, what am I referring to? Clearly referring to. Okay, just want to kind of finish that thought. And also with screencast, you do want to kind of take the notes with me here, because I am really actually finishing kind of the story we began in class. I'm finishing the story of that first limit there, okay? And I think it was Adam Bazone in my third floor section that said, you know, so really when you have an indeterminate limit, as this was, your task then becomes really showing that it is non-existent by looking at paths, okay, paths of the xy plane, that pass through the point of question that yield contradicting z values. And once you find a contradiction, the limit doesn't exist. Now, I bet you're curious, right? What does this function look like graphically such that as xy approaches 0, 0 doesn't exist? Well, let's take a look. I found it over here for you. Look at that. And if you look at this function, here is that function f of xy, and the point 0, 0, you have to make sure you orient yourselves correctly here. Here is the x-axis. Here's the x-axis. You see that right there? My stylus is making it want to turn. Here's the x-axis, and here you'll notice 0 right there in the middle. Then here's the y-axis. You see 0 in the middle. But look at the z-axis over here. That z-axis, 0 is in the middle of the axis that's drawn. And if you look at the surface, point 0, 0, to see the three-dimensional version of what you've called a corner point or a cusp last year, right? And so you know that you're suspecting it's non-differentiable, but if you look at this, it looks like, if you take a look here, that 0 over 0, 0, 0, 0, excuse me, at x equals 0, y equals 0, it is, you know, no graphic is perfect, but it's possible, only because it's not crystal clear, it's possible that the z value being approached is different depending on the path that you are traversing. And if you're really savvy, check this out, look over here. If you're really good with your graphics, you can even see the curve y equals cube root of x, that you can even see the path. Do you see it, everyone? When I go like this, it's like, oh, see, when I try and use my stylus to point to show you, it's kind of moving around, but can you check it out? Look at that. Check it out. You can see the roller coaster track, so to speak, above y equals cube root of x. It's kind of neat. So that was a nice kind of conclusion to our conversation. All right. So like I said, when I see you next class tomorrow, we're going to continue this idea of a limit with another problem. All right. But it's just kind of nice to tie up. Okay, and I'll go back here to where I left off. All right, goodbye everyone, and I hope you enjoyed this screencast.